So let us start from the last class of the thermodynamics. Right. So in the last class, we have this last topic was the Gibbs free energy. Right. So what is the Gibbs free energy? The amount of energy utilized to do the work is called Gibbs free energy. Right. So next, how to find out what is the formula for Gibbs free energy? Delta G is equal to delta G is equal to delta H minus T delta S. Okay, so whenever what is the purpose of studying delta J? It helps us to know whether the reaction exists or doesn't exist, or else you can say spontaneous, non-spontaneous. Okay, right. So let us try to understand. Whenever the delta J is positive, not spontaneous, negative, spontaneous, zero is what? Equilibrium. Based on the nature of delta S and delta H, whenever the delta H and delta S both are plus, what happened? The reaction, high temperature spontaneous, less temperature non-spontaneous. Opposites of this what? Minus and minus. So when both delta H and delta S are minus and minus, what happened? So before, high temperature was spontaneous, but now high temperature is non-spontaneous. Before, the low temperature was non-spontaneous, now the low temperature is spontaneous. Okay, that means if you just by heart the first two columns, then opposite of them will be acting as what? Answer is also going to be opposite. Okay, right. So let us continue from here. So finally, what you can say here, the formulas are okay. So let us try to write down the formulas of what? Formulas of Gibbs free energy. Okay, so let us try to write down here the formulas. Okay, let us try to understand what are the formulas. Finally, formulas of the Gibbs free energy. What is the first formula? Delta G is equal to delta H minus T delta S. Okay, if you are taking under standard condition, what is the formula? Delta G naught is equal to delta H naught minus T delta S naught. Okay, so here this is what? Under standard condition. Okay, under standard conditions. Okay, right. One more thing, third formula, the formula for the delta, if they provide the chemical equation. Okay, sometimes what happens, they provide the chemical reaction. Okay, so whenever they provide the chemical reaction, how to find out the delta G? So delta G naught is equal to delta G naught of products. Okay, product minus delta G naught of reactant. Delta G naught of what? Reactant. Brothers product minus reactant. Okay. Next here we have to remember some important point regarding the delta G naught. Okay. What is that? Some important point. The important point regarding delta G naught is nothing but for standard forms. Okay. For standard or you can say for stable form. Okay, for stable forms, what is the specialty of delta G naught? Value is always equal to 0. Okay, standard Gibbs free energy is always equal to 0. Who for whom? For the one who are in the stable forms. Okay, well let us try to write down the examples of what? Examples of the stable forms. Okay, so let us try to understand what are the examples of stable forms. Example, so example is nothing but, for example, if I talk about sodium, can say sodium is a metal. What is the stable form of sodium? So the stable form of sodium is what? Solid state. Okay, suppose if I write H2, H2 is what? Stable form of high hydrogen. H2 is what? Gas form. Okay, for them delta G naught is always equal to 0. What is the meaning of delta G naught? Standard Gibbs free energy. Okay, if I write chlorine, what is the stable form of chlorine? Gas. Okay, fluorine, what is the stable form of fluorine? Gas. Fluorine, chlorine. Next, bromine. What is the stable form of bromine? Liquid. Okay, stable form of iodine is what? Solid state. Right. In the same way, stable form of mercury is what? Liquid. Okay, stable form of carbon is what? Graphite form. Okay, so whenever you get any stable forms, for them delta G naught value is acting as what? Delta G naught E value is always equal to 0. Okay, right. The delta heat, that is Gibbs energy of formation. Right, now moving to the next concept. Then the next, the last one is nothing but third law. Okay, third law of thermodynamics. Third law of thermodynamics, which is nothing but third law of thermodynamics. Okay, so what does the third law of thermodynamics says? Let us try to understand. Okay, generally what we say that is it easy to find out the entropy? No. Can we find out the exact value of entropy? No. But can we find out the the change in entropy. Yes, this is what we have studied in the entropy concept. What does entropy concept says that we cannot find out the exact value of entropy, but we can find out the change in entropy. But third law says that finding the exact value of entropy is possible. Okay, what does the third law says? Third law says that finding the exact value of entropy is possible, but there are few conditions. Okay, what are those conditions? If the conditions are satisfied, then only you can find out what exact value of the entropy. And what is that condition? So whatever the sample we people are taking, no, that sample must be what? Pure, perfectly crystalline substance. Okay, whatever the substance you people are taking, now they take, what is the first condition? The first condition is nothing but whatever the sample your people are taking, the sample must be what? Pure and perfectly crystalline. Okay, pure and perfectly crystalline. Okay, next, at what temperature the substance should be? The temperature, at what temperature? The temperature must be at 0 Kelvin. Okay, what is the temperature? Temperature must be what? 0 Kelvin. Under these conditions only, under this condition only, you can find out the exact value of the entropy. And what is the exact value of entropy? It was found 0. Clear till here? Repeating again, it is impossible to find out the exact value of entropy, but third law of thermodynamics says that it is possible to find out the exact value of entropy. But what is that condition? The condition is certain, but whenever you take any substance, right? For example, I am going to give one sample, okay, and I will ask you to find out the exact value of entropy. So what you have to do? You have to apply the third law of thermodynamics. What does the third law of thermodynamics says? Whatever the sample you people are taking, now what is the nature of the sample? The nature of sample should be pure, perfectly crystalline. And when you can find, whenever you have to provide what temperature? At 0 Kelvin. Okay, after providing this temperature, what is the exact value you will get? The exact value was found to be 0. Okay, the value was found to be how much? 0. Okay, it's not necessary that value should be greater than 0. 0 is itself is a value, right? So what happened? Exact value you can find out at which condition? At 0 Kelvin. And what was the value? Value was found to be 0. Clear till here? Right, so moving to the next one. Right, so this is about what? This is about first part of the thermodynamics. Right, so now let us try to understand the second part of thermodynamics, which is nothing but thermochemistry concept. Okay, so second part of the thermodynamics is what? Thermochemistry. Thermochemistry. So what is that? What is the meaning of thermochemistry? Till now we have studied just entropy, enthalpy, everything. Okay, but now we are going to study how thermodynamics is involved in the chemical reactions. Okay, based on thermochemical reaction. Okay, all the chemical reactions which is dealing with thermochemistry are called thermochemical reactions. Okay, so based on the delta H value. Okay, based on the delta H value, how many reactions we have? Two reactions. What are those? Exothermic. Okay, exothermic chemical reaction. Other one is what? Endothermic, based on delta H value. Exothermic chemical reaction, endothermic chemical reaction. When you should say exothermic chemical reaction, what is the meaning of exothermic chemical reaction? Whenever in the chemical reaction, heat, or you can also call it as a energy. Okay, the chemical reactions in which heat, or you can say energy, is released, then those type of chemical reactions is called exothermic. What is endothermic reaction? The chemical reactions in which heat or energy, okay, is absorbed, then those reactions we should call it as endothermic reactions. Okay, now what happened here? How to find out? Just by seeing the chemical reaction, which is exo or endo. Right, for exothermic, what happened? The delta H value, okay, the delta H value will be negative. For endothermic, what happened? The delta H value should be positive. Clear till here? Right, so in the moving to the next part, how to identify. Okay, now they will provide some chemical reaction samples, and you have to answer whether there is a exothermic or endothermic. Okay, let us take few examples. I will provide 4 examples. In the first example, A plus B gives rise to C plus D plus small q. Okay, what is the meaning of small q? Heat. Okay, here what is the meaning of q? Heat. Okay, what is the meaning of C and D? Product. What is the meaning of A and B? Reactant. Okay, this is the first example. Next, the second one. The second one is A plus B gives rise to C plus D minus Q. Next, third example. A plus B gives rise to C plus D. Delta H is equal to negative. Okay. Next, fourth one. A plus B minus Q gives rise to C plus D. These are few examples. Okay, we'll get a lot of examples, but we will solve only 4 examples for now. Okay, now for the given reaction, we have to find which one is a exothermic, whether the first reaction is exo or endo. Okay, so always remember here in third reaction is very easy to know whether it is exo or endo. Why? Because delta H value directly they have provided. So what is the delta H value? Negative. Whenever the delta H value is negative, the given chemical reaction is which reaction? Exothermic reaction, right? Now let us try to understand here next one, first one. Okay, but in the first one they didn't provided the delta H, but what they did, they provided the Q value. Okay, now always remember, if you want to know whether the reaction is exo or endo, heat must be in the left side. What happened? Heat must be in the left side. But in this reaction, what they have provided? They have provided in the right side. So how to identify? Just send the heat towards left side. So here you have plus Q. Okay, if I send left side, what you will get? Minus Q. And we know that minus indicates what? Exothermic. So that means the given belongs to what? Exothermic reaction. Okay. In the second reaction, what happened? Heat is provided. So how to identify whether it is exo or endo? Just shift the heat towards left side. So minus Q will become, when it goes to the right side, left side, what you are going to get? Plus Q. We know that plus indicates what? Endothermic. So therefore the given representation belongs to what? Endothermic reaction. Okay. Coming to the fourth one, the heat obviously already they have provided in the left side. Just by seeing left side, you can identify heat. Minus means indicates what the question belongs to. The given example belongs to exothermic reaction. I hope you people understood how to find out exothermic and endothermic reaction. Right, now moving to the next one. The next concept is types of delta H. Okay, types of delta H. Okay, so let us try to understand here what are the types of delta H here. Right, so in the delta H, what happened? First type, the first type is nothing but enthalpy, standard enthalpy uh, of reaction. Standard enthalpy of reaction, which is nothing but delta HR. Okay, since standard is given, I'm going to write here 0. Okay, which is also known as, there is one more name for standard enthalpy of reaction, which is nothing but standard heat of reaction. Heat of reaction. There are total 2 names for the heading. What is that? Standard heat of reaction or standard enthalpy of reaction. Okay, but whatever it is, in these headings, what happened? Enthalpy, heat, both are same, right? So now what happened? It is denoted by which letter? Delta H naught R. Okay, so what does the conditions they say? What is the meaning of standard condition? First of all, okay, what is the meaning of standard condition? When you should say that the chemical reaction is under standard condition, whenever the pressure is what? 1 atmosphere. Okay, and the temperature must be 298 Kelvin. At this condition, you can say that the chemical reaction is under which condition? Standard condition. Okay, now what are the conditions? Okay, when you should say that the question belongs to enthalpy of reaction, standard enthalpy of reaction. What is the condition? First of all, the chemical reaction. Okay, the chemical reaction must be balanced. Must be balanced. Then only you can say that for the given chemical reaction, delta H not R is, or you can say delta H is eligible. Okay, right. So let us take few examples here. I will write 1 to 2 examples. You have to answer that whether it is showing delta H not R or not. Okay, right. Just I'm leaving the, I'm just not taking under standard condition. Okay, if you take standard condition, then what you choose the delta H naught. Okay, HR naught. If they didn't provide this standard condition, then how you will denote it? Delta HR. That's it. What is the meaning of delta HR? Enthalpy of reaction, or else you can say heat of reaction. If they provide standard, then what you should say? Standard enthalpy of reaction. Okay, first example. Okay, in the first example, what I will do? I will write H2 plus Cl2 to gives rise to HCl. Okay, in the second equation, what I will do? I will take it as what? CaCO3 gives rise to CaO plus CO2. Okay, so let us see out of 2 who is eligible for delta HR. Okay, what is the condition for delta HR? When you should say the question is eligible for delta HR, only one and only one condition. What is that? Chemical reaction must be balanced. If it is not balanced, then you cannot apply the formula of what? You cannot apply the concept of delta HR. Okay, so here what you have? 2 hydrogens, 2 chlorines, but you have here 1 hydrogen, 1 chlorine. Can you say it is not balanced? Okay, so it is not balanced. So it is not balanced, hence therefore you cannot apply the concept of delta HR. Okay, here the chemical reaction is balanced. right? In the second case, the chemical reaction is balanced. Hence, you can use the concept of what? Delta HR. We are just checking eligibility now. Okay, we are just checking eligibility, that whether the chemical reaction is applicable for our concept or not. Clear till here? Next, coming to the formula. Okay, so just the thing you have to do in this chapter is just try to remember the formula. So what is the formula of delta HR? Delta HR is formula is nothing but delta H of product minus delta H of reactant. Clear till here? Just remember product minus reactant or reactant minus product. Clear till here? Right. Moving to the next one. The next one is nothing but enthalpy of formation. So the second one is nothing but what? Not second one. Okay. So now who is the head, Nana? Out of all. Okay. Let me explain you. There is one head and the head name is what? Delta H. And what he is going to do? He is going to control remaining everyone. So out of everyone, let us try to understand the first one. The first one is what? Heat of formation. Heat of formation. Okay, if I use the standard condition, then what you should say? Standard heat of formation. Okay, so how to denote heat of, what is the other name of heat? Enthalpy. You can call it as a enthalpy of formation, or if you want, you can call it as a heat of formation. So how to denote heat of formation? Enthalpy means what? Delta H. Formation means what? F. So whenever you see this symbol, what is the meaning of this symbol? Enthalpy of a formation. Okay, if I write delta H not F, what is the meaning of this symbol? Standard. Okay, standard enthalpy of formation. Clear till here? So when you should say that the chemical reaction is eligible for standard enthalpy of formation, so let us try to understand what are the condition, how to identify whether the chemical reaction is eligible for heat of formation. Okay, the first condition is what? Whatever the products you people are going to see in the chemical reaction, the product must be how many moles? The product must be 1 mole. Okay, and second one, reactant must be elemental form. Reactant must be what? Elemental form. Okay, what is the meaning of elemental form? What is the elemental form of oxygen? O2. Elemental form of sodium? Na. Elemental form of hydrogen? H2. Elemental form of iodine? I2. Elemental form of nitrogen? N2. Okay, if I ask you what is the elemental form of oxygen? O2 or O3? Answer is what? O2. I hope you people understood the meaning of elemental form. Next, reactant product. All compounds of reactant product must be in the stable form. Okay, third one is what? All reactant and product must be in stable form. Okay, I hope you people understood what is the meaning of stable form. Okay, what is a stable? For example, if I ask you what is the stable form of chlorine? Cl2 gas or Cl2 liquid? Which one is a stable form of chlorine? Gas form is a stable form. I hope you people understood the difference between elemental form and stable form. Elemental form is not related with physical state, whereas stable form is related with what? Physical state. Okay, let us take few examples here. Right, so the first example, carbon diamond form. Okay, reacts with oxygen, which is in gas form, will gives rise to what? Okay, carbon dioxide gas form. Okay, so let us try to understand how to know whether the reaction is eligible for heat of formation. What is the first condition? The first condition is nothing but what? Product must be 1 mole. Okay, so do you have product to 1 mole? Yes, product is 1 mole itself, right? So that means first condition is satisfied. What is the second condition? Second condition is nothing but reactant must be elemental form. Okay, can say elemental form of oxygen is what? O2. Very good. Elemental form of carbon is what? C. Correct. Okay, elemental form of carbon is C or C2. Obviously C. Okay, so that means second condition is also satisfied. What is the third condition? All reactants and products must be in stable form. Can say carbon dioxide stable form is gas? Yes. Oxygen stable form is gas? Yes. Carbon stable form is diamond? No. What is the stable form of carbon? Graphite is the stable form of diamond, so carbon. So hence third condition is not satisfied. Therefore, what you can say, delta HR is not equal to delta HF. Clear till here? Right? Why I'm comparing with delta H? Because delta H is the head of this chapter. It is going to control everyone. Okay. So moving to the second example, let us try to understand here second example. So in second example, what I'm going to do? I'm going to take here carbon monoxide gas, okay, plus half times of oxygen gas, okay, will gives rise to carbon dioxide gas. Clear till here? Right, so let us try to understand whether it is eligible for heat of formation or not. What is the first condition in heat of formation? Product must be 1 mole. Do you have 1 mole of product? Yes, the first condition is satisfied. What is the second condition for heat of formation? Reactants must be what? Elementary form. What is the oxygen elementary form? O2. Okay, it's for what is the elemental form? Can I say carbon monoxide is not a elemental form, it is a molecular form. Yes or no? You have carbon and oxygen. Carbon oxygen combining will not give the elementary form. Okay, so that means second condition is not satisfied. Let us take about third condition. What is the third condition? Stable forms. Everyone should be in the stable form. Carbon dioxide is in the gas form, stable form. Oxygen is in the gas form, stable form. Carbon monoxide is a gas form, stable form. So all three are stable. But if can I say second condition is not satisfied, if at least one condition is also not satisfying, then immediately what you should say, delta HR is not equal to delta HF. That means heat of formation concept is not eligible for this reaction. Okay, let us go for the next one. Third example. Okay, H2 gas reacts with Cl2 gas. Okay, to produce what? 2 times of HCl gas. Okay, so let us check whether the question is eligible or not for heat of formation. What is the first condition for heat of formation? Product must be 1 mole. Can say here products are 2 mole, so hence first condition is not satisfied. What is the second condition? Reactants must be elementary form. Chlorine elementary form is Cl2, hydrogen elementary form is H2, so hence second condition is satisfied. What is the third condition? Third condition is nothing but what? Everyone should be in the stable form. HCl is a gas form, chlorine gas form, hydrogen gas form. But since first condition is not satisfied, so immediately what we can say, delta HR is not equal to delta HF. Okay, let us go for the fourth example. So in the fourth example, what I'm going to do, I'm going to take half times of H2 gas. Okay, reacts with half times of Cl2 gas, right, will gives rise to what? HCl gas. Okay, let us check whether the chemical reaction is eligible or not. What is the first condition? First condition is what? Product must be 1 mole. Do you have product 1 mole? Yes. What is the second condition? Reactant should have elementary form. Chlorine elementary form is Cl2. Okay, hydrogen elementary form is H2. Okay, that means second condition is satisfied. What is the third condition? Everyone should be stable. HCl gas form stable, chlorine gas form stable, hydrogen gas form stable. Can say all the three are eligible here. So therefore, what you can write here, delta HR is equal to delta HF. That means heat of formation is eligible for this concept. Clear till here? I hope you people understood how to identify which chemical reaction is eligible and which chemical reaction is not eligible. Right, move to the next heading, formula. Okay, so coming to the formula, delta HF formula is nothing but what you can write, delta that is nothing but HF, heat of formation. Okay, heat of formation of product minus heat of formation of reactant. Okay, the only thing you have to remember is whether it is a reactant minus product or product minus reactant. Clear till here? Next one important note. So what does that important note says that delta HF naught. What is the meaning of delta HF naught? Standard enthalpy of formation will be equal to 0 for whom? For stable forms. For whom, Nana? For stable forms. Okay, best examples of stable form is what? What is the stable form of hydrogen? Gas. Okay, let us take few examples of stable forms here. So H2 is what? Gas. Okay, whereas for fluorine is gas. Okay, chlorine is also stable form is gas. Okay, what about bromine stable form is liquid. Iodine stable form is solid, right? Next elements, sodium is a metal means solid. Magnesium is also metal, solid. Okay, right. Next, what you can say, um yeah, I know one more thing is stable forms for elements. Very important. Elemental form, not for the this one. For example, if I take H2O liquid, stable form of water is liquid, but you cannot take this example because this is a molecule. We have to talk for the only for elements. Okay. Next, carbon. What is the stable form of carbon element? Graphite. Okay, graphite is a stable form of carbon. Okay. Right. So these are few examples here, but there are few exception. Okay, right, so there is one exception. Okay, what is that exception? Phosphorus. Okay, generally phosphorus is of two types. Okay, white color phosphorus and one more is nothing but black color phosphorus. Okay, so what happens in white color? Generally, if I ask you stability order, okay, stability order, what is the stability order? Black is more stable than white. Okay, then what do you think for whom delta H naught F will be 0? We think that since the black one is more stable, so black one should have the 0 value. Okay, but it was considered for delta HF is equal to 0 for whom? For white one. Okay, though black one is more stable, but for which one H naught F is 0? For white phosphorus, delta H naught F is 0. Clear till here? Which one? Some more important points here. Two important points we people are going to study. The first important point is all combustion reactions. Okay, all combustion reaction are exothermic reaction. Are exothermic reaction. This sentence is true or false means you have to answer false. The reason why this is false nothing but not all combustion reactions are false. There are few combustion reaction where you can say they are endothermic also. For example, if I write CH4 plus O2 gives rise to CO2 plus H2. What is the meaning of combustion reaction? Combustion means what? Reaction with the O2, right? So now what happened here? Though it is react, so this is an example of what? Exothermy. But when I take N2 plus O2, which is nothing but you may get different products based on the concentration, based on the available conditions, environment. Okay, you may get N2O4 or you may get NO, okay, etc. But this reaction is considered as what? Endothermic. Though it is reaction with oxygen, though it is a combustion reaction, but it is what? Endothermic reaction. So whenever you get the sentence all combustion reactions are exothermic, it's completely false sentence. Okay, right? In the same way, second one, right? If they say all neutralization reaction, okay, all neutralization reactions are exothermic. Okay, so whenever you get this exothermic, okay, so absolutely you have to say true. Okay, there is no exception. All neutralization reactions are exothermic, and this is a completely correct sentence. Okay, so now they will say, ma'am, what is the meaning of neutralization reaction? Neutralization reaction is nothing but when acid reacts with base, what you are going to get? Salt plus water. Salt plus water. So these reactions are what? Exothermic reaction. It's completely true. Okay, right. So let's go next one with the third one. So the third one is nothing but heat of combustion. Okay, heat of combustion. So let us try to understand heat of combustion. So how you will denote the heat of combustion? Heat indicates what? Delta H, combustion means C. So whenever I write delta HC naught, what does it indicate? Standard enthalpy of combustion, or else you can call standard heat of combustion. Okay. So let us try to understand here like change in 1 mole. How to identify whether the question is eligible or not, whether the chemical reaction is eligible or not. Okay. Let us try to understand what is the condition. Okay, so what is the first condition here? Reactant must be 1 mole. Okay, so here reactant, okay, must be how much? 1 mole. Okay, next. Second condition is what? There should be a complete combustion. Complete combustion. Now we'll say, ma'am, how to know whether the question is a complete combustion or not? Okay, remember in complete combustion what happened? You will get carbon dioxide as a product, and water must be in which state? Liquid state. Then only you can say that the question is complete combustion. Don't worry, when we'll do few questions, then only you will get some idea. Okay, you'll get some idea. Okay, let us take first of all. Okay, the first one is nothing but C diamond. Okay, C diamond reacts with O2 gas to produce CO2 gas. Okay, so how to know that delta H combustion is there? What is the first condition? Reactant must be 1 mole. Can say carbon is 1 mole, right? And remember here reactant means who, Nana? Here reactant means what? Other than oxygen. Other than oxygen. Why other than oxygen? Because oxygen itself is a combustion. For combustion, obviously oxygen we require very excess amount. So never consider oxygen as a 1 mole. If oxygen is more than 1 mole also, it's fine. So which one should be 1 mole other than oxygen? Okay, here carbon other than oxygen means what? Carbon is 1 mole. Hence the first condition is satisfied. What is the second condition? The second condition what they have given? Complete combustion. How to identify complete combustion? The product might be carbon dioxide or water. Okay, so can say carbon dioxide is there. Yes, so therefore you can say that Both conditions are satisfied. Hence, what you can say, delta HR is equal to delta HC. That means heat of combustion is eligible for the given reaction. Okay. Let us take one more example here. Right. So this time what I'm going to do, I'm going to take here C graphite. See, they didn't in the heat of combustion, no need of focusing whether the compound is stable or stable form or no, another form. Okay, because the condition related to the combustion is what? Only two conditions. What are those? Reactant must be 1 molar, and what is the second condition? Obtained products must be complete combustion products. Okay, since C graphite required reacts with half times of oxygen gas, okay, will give rise to CO gas. So let us try to understand whether it is eligible or not. Right. So first condition, what is the first condition? Reactant must be 1 mole. Who is reactant here? Carbon is the reactant. Don't say that ma'am oxygen is half. Leave it oxygen. Okay. So here how many moles? 1 mole. Then that means first condition is satisfied. What is the second condition? Complete combustion. Right. So when you should say complete combustion, can I say do you have carbon monoxide? When you should say complete combustion, product must be carbon dioxide, or when if you get anywhere water, then that water must be in the liquid state. Since there is not nothing like that, second condition is not satisfied. Hence what you can write, delta HR is not equal to delta HC. Clear till here? I hope you people understood this. Right, now moving to the next one, formula. What is the formula for heat of combustion? Okay, so the formula for heat of combustion is nothing but delta HC is equal to heat of combustion of this time you have to take reactant. Very, very important. First time you people are seeing about what? Reactant minus heat of combustion of what? Product. Heat of combustion of reactant minus heat of combustion of product. Clear till here? If they provide standard condition, you have to take what? Standard condition. Okay. Standard heat of combustion of reactant minus standard heat of combustion of product. Okay. So till now, how many headings we have completed? 3 headings. What is the first one? Heat of formation, right? So for heat of formation, what is the formula? Product minus reactant. Next, what we studied? We studied enthalpy of, what is the second one we have studied here? Formation. Next, yeah, heat of reaction was the first one. Okay, okay. Second one or third one, this is the second one. Heat of combustion is the second one. Okay, right. So first of all, right, delta HR, what is the formula for delta HR? Product minus reactant. Third one is what? Delta HC. Combustion is what? Reactant minus product. Okay, right. So let us go for the next one. This is about second one. Let us go with the next one, third heading, right? So coming to the third heading, the third heading is nothing but standard heat of neutralization. Okay, standard heat of neutralization. Neutralization. Okay, so denoted by what? Delta H naught NEU. If they provided standard, then you can use 0, or else you can just write delta H NEU. Okay, so here what happened in this case? What is the meaning of standard heat of neutralization? When 1 gram equivalent of strong acid, okay, reacts with 1 gram equivalent of strong base, okay, then the heat released, okay, then the heat released is how much? Minus 13.7 kilocalories. Minus 13.7 kilocalories. If you're taking other than this combination, what happened? You will get some other values. Okay, kilocalories, or else you can also write minus 57.1 kilojoules. Minus 57.1 kilocalories, or minus 13.7 kilocalories, or minus 57.1 kilojoules. Okay, so remaining part we'll discuss in the next